Okay, I'm going to do section 5 too. I'll look at multiplication as repeated addition first. So we'll look at 3 times 2. And a big key here is start with 0. Or start at 0. So, with the chip model, I'm going to do 3 groups of 2. So I've got 2, I add 2 more, I add 2 more, so we got 3 times 2, it's 2 plus 2 plus 2 is 6. Okay, let's tie this to the number line. Same kind of thing, we're starting at 0. And we're going to add 3 groups of 2. You probably saw it as there's plus 2, plus 2, plus 2. Again, we end up at 6. Well, we can do the same thing with positive times negative. Let's do 3 times negative 2. Again, we're starting at 0. I'm doing negative 2, negative 2, and negative 2. And we learned with addition that when we add these negative numbers, we're actually moving to the left on the number line, and we got an answer of negative 6. So we tie that to our number line then. Starting at 0, we know if we add a negative 2, we're moving 1 or 2 units to the left. Do that 3 times, and we end up at negative 6. Now, here's the big one. This is on page 231, I believe. If we were in class, you would do this as a lab and you would develop this yourself. Somebody always comes up with it. How do I do negative 3 times negative 2? And it's not poof, poof, swish. It's not 2 negatives makes a positive. We want a physical model for this. That's where the chips come in. And here's our big key. Starting at 0. The idea of 0 pairs. By the way, all this stuff I'm doing, think Lesch's model. Diagrams, symbols, manipulatives. There's probably a homework in there somewhere, for sure. Okay, now here's what we do. When we did 3 times negative 2, we interpreted that 3 as add 3 groups of negative 2. Now we're going to make a new interpretation. This is the key to this. This minus sign now says take away 3 groups of negative 2. So now I'm going to take away 3 groups of negative 2. There's 1, 2, 3, and look what we did. We ended up with positive 6. There was no poof, poof, swish, magic in there, just a different interpretation of what that's telling us. Now, we want to see if our model is consistent. So I'm going to change our problem a bit. And I'll give you a little time to think about this one. What if I did -3 times 2? What's the interpretation here? Maybe pause the video and think about it. See if you can look ahead as to what I'm going to do. Going to take away 3 groups of +2. 1, 2, 3, and we ended up with our answer of -6. So our model was consistent anyway. So now let's see if I can tie this to the number line, since I just did this one. Let's build me a number line. I'm at 0. And I'm saying, okay, I want to take away 3 groups of 2. Well, I know that if I'm here and I take away a group of 2, I'm going to the left, 2 units. Take away another group of 2, I'm here. Take away another group of 2, I'm there. It's kind of like repeated subtraction. Okay, that's the chip model with multiplication. I want to show you 2 other things. There's a kind of a new property with multiplication here. It's the 0 property. Hopefully you've been reviewing all your commutatives and all that stuff. Basically it says if you have a number times 0, you get 0. We know that 5 times 0 is 0. Well, the reason this becomes important down the road is when students get into algebra and they need to solve a quadratic equation. I don't know when's the last time you did this. You may have done this once in class. Remember, you learn to factor. And here's where that property comes in. I've got this times that. Well, if this thing is 0, meaning if x is 3, then 0 times whatever that is 0 because of our property. And if this factor is 0, or if x is -2, we get the same thing. This becomes 0. 0 times anything is 0. Okay, one last thing. I'm going to quickly do division the way the book does it. I hope to explore this in a lab over Zoom somehow on Thursday. We'll figure something out. I want to look at division. And notice in the book, this always kills me. I'm going, God, I wonder how they're going to do the chip model with division. And the authors kind of just gave up, I guess. They do the definition of division like this. 12 divided by 4 is 3 because 12 equals 4 times 3. This is the same thing as, remember, 4 divides 12 because there's a number such that 4 times 3 is 12. Same thing as divisibility. I hope to explore that with the chip model with you live, or if not, I'll figure out an assignment or something. Bye.